Today we're going to talk about evidence for evolution, and we're also going to talk about patterns in macroevolution as well, but we wouldn't be able to see the patterns without the evidence, so the two kind of go hand in hand. So if we look at the fossil record, we're going to see a lot of fossils of various ages. We're not going to see all the fossils because only certain structures fossilize, and generally their bodies have to be trapped underwater and then silt and sediment, and that prevents oxygen and quick decay. So it allows that slow process of turning bone into rock. Fossils are actually laid down from bottom to top as new layers of sediment are laid down over the old. So fossils are youngest near the surface and oldest near the bottom, and that's also known as the law of superposition. But we've got the movement of tectonic plates at play here, so there's lots of folds that have happened. Things have been pushed down, things have been pushed up. That can destroy fossil remains. But we've actually found a lot of places on Earth where different ages of fossils and different ages of rock are exposed in layers. This is especially true where like rivers have carved into mountains, or here you're seeing, I think, ocean that has carved down this cliff face here. Having exposed rock has allowed us to find transitional fossils, those are organisms whose fossils show us a link between great forms of life because they have characteristics of both. So we're often seeking out these forms in rocks of a certain age because they mark a period between two forms. So we had evidence that suggested that modern whales were related to land mammals, but you could see and you can see in the picture that the nostril positioning didn't match, and so that indicated that there might be a transitional form with an intermediate nostril position. And so sure enough, we did find one, and one hypothesis at a time, we're filling in gaps in the tree of life with transitional fossils, and that can lead us to even more detailed hypotheses and increased odds of more discovery. So this is a very specific example. We have, some just classic examples. Tiktaalik, discovered fairly recently, around 2004, showing us fish with characteristics of tetrapods and modern amphibians. And so that's a classic transitional fossil, Tiktaalik. And also we've seen transitions in the fossil record between reptiles and mammals. And you can look at the million years ago, the MYA, and see that this is in order, oldest to youngest fossils. And so that's where we're using transitional fossils to help us ask and answer questions about the history of life. If you look at the fossil record overall, in some places you're going to see gradualism, where a single type of organism seems to change slightly over time, each time with a new addition or subtraction from the basic body plan. And, these are different species, often very different species from very different time periods, but you can see this gradual change from oldest to youngest fossils. But that was fairly easy to explain and, fairly expected in the fossil record. The pattern we call punctuated equilibrium, where rapid bursts of change in species are followed by relatively little change, did puzzle us a bit more, where we see in many fossil layers, so like here, you're not seeing a lot of change. So there was stasis or equilibrium, and then some situation or change in the environment promoted rapid change, and then again after that period of rapid change there was very little selective pressure to change, and again leading us to see stasis. And so the fossil record really shows both patterns. The more we're finding out about fossils and trends that we see, we're actually seeing both. And adaptive radiation is related to punctuated equilibrium. It kind of helps explain it.